Hello all, we see values of permittivity and loss tangent of a PCB material in this snapshot. So this is from Isola 370HR PCB material, and you can see here the permittivity, that means the dielectric constant of this is around 4. This is the one which we use in our PCBs commonly, right? Now there is one more parameter here which is called loss tangent, or this particular specification is also called dissipation factor. So what I mean by loss tangent or dissipation factor is when a signal travels down on a PCB, the amount of losses that a signal undergo on a transmission line of a PCB is known by the loss tangent. That means losses incurred by the signal when traveling on a PCB. So if we see here, for different frequencies the losses are different. That means in a PCB, based on the frequency, the losses are going to change. As the frequency increases, losses are going to increase. So if you see here, for 10 GHz signals, the loss tangent is around 0.025. This is in dB per inch, and so this basically is, so we calculate the loss tangent using like we determine the loss tangent using the attenuation that is seen. That's what the definition is, right? So attenuation is basically dB per inch. Loss tangent is a plane figure. Okay, we do not have any units. So now if you see here, as the frequency increases, the loss tangent value is increasing, that or the dissipation factor value is increasing, which means the losses in a PCB will increase, which is very important to know. So this material selection, we mean the PCB material selection, depends on the loss tangent value as well. The graph we see here is attenuation versus frequency. So you can see here frequency is on x-axis, attenuation, which is dB per inch on a PCB material, is on the y-axis, and frequency versus attenuation is drawn for different dielectric materials. This is from the Intel website, where different materials attenuations have been mentioned. We can see here the magnetron 6 material, which is having a frequency versus attenuation graph, which has the lowest losses here, whereas the Isola 370HR, which we talked, right, this has higher losses. And then as we go on, we can from Isola 370HR to Nelco material for Nelco 4000, or if we are going to some other series in Nelco or Rogers, so the attenuation has improved. So what Intel mentions is they have used the Megatron 6 material from Panasonic for their high frequency board successfully. So as frequency goes on increasing, it is important that we consider the losses and select the PCB material.